All right. So today we're going to look first at perpendicular bisectors. And back in the first chapter, we constructed perpendicular bisectors. We did a perpendicular bisector construction. Okay? To do that, what we did is we took our compass about yay long and we went whoop, there, and then we went, I can't even hold it. That's really bad. Let me try that again. So we took our compass, made an arc like this, went to this side, made an arc like this. Oh, so much better. And then we drew through there, and that was our perpendicular bisector. Now, any point on the perpendicular bisector is the same distance from the endpoints. So the distance from here to here and here to here will be the same. How could I check that with the compass? Well, I can take my compass, go here, and go, this distance is the same as this distance. I can go from here, where they marked, and I go, this distance is the same as this distance. So any point that happens to be on the perpendicular bisector of a segment is the same distance or equidistant from the endpoints of that segment, which it says right here. And it's called the perpendicular bisector theorem. Oops. I need to go here. The perpendicular bisector theorem, which says if a point is on the perpendicular bisector, it is equidistant from the endpoints of the segment. So if a point P is on the perpendicular bisector of xy, P is the same distance from x that it is from y. Okay, the perpendicular bisector theorem. Now we have a converse to the perpendicular bisector theorem, which says if P is an equal distance away from x and y, the endpoints of a segment x and y, P will be on the perpendicular bisector of x and y. So that means this is a perpendicular bisector. Okay? That's the converse of the perpendicular bisector theorem. All right, how do we use that? Well, we use it like this. Okay, here's a proof. Actually, here's a proof of the perpendicular bisector theorem. Okay? What it says is, if we start out with these two angles being congruent, because all right angles are congruent. So these two angles are congruent. And if we know that PQ is congruent to itself because of the reflexive property, and that XQ is congruent to XY or YQ because Q is a midpoint of XY and perpendicular bisector hits it at the midpoint. This triangle on the left is congruent to this triangle on the right because of side, angle, side. Side, angle, side. Okay, so by side, angle, side, these two are congruent. Then by CP, CTC, PX is congruent to PY. So that proves that any point on the perpendicular bisector is going to be the same distance away from the endpoints. So here's Mr. Lee, and here's his conundrum. Mr. Lee has an ice cream cart, and basically it's a food truck, okay? Say he has a food truck, and he needs to park the same distance away from the park entrance as it is from the zoo entrance. Where should he park along the street so he's the same distance away from the park entrance and the zoo entrance? Well, if you draw a segment between the park and the zoo and draw the perpendicular bisector And where it meets up with the street, that's where he should park his food truck, right at T, because T is on the perpendicular bisector, so it's the same distance away from the zoo entrance as it is from the park entrance. Okay? That's using a perpendicular bisector. All right. Now, looking at this, we know that AB has to be congruent to AD. How do we know it? By the what theorem? Perpendicular bisector theorem. So since we know these are congruent, what is the length of AB? Well, to figure out the length of AB, what do we do with those two expressions, Caitlin? Put them equal to each other in an equation. So 6x minus 10 equals 3x plus 2. First step of solving that equation, Chase, what do?
You move the 10.
I don't like moving numbers that aren't variables first. We want to move the variables first.
Move the 3x.
Move the 3x. Move the smaller variable, so subtract 3x from each side. So I get 3x minus 10 equals 2. What's my next step, Isaiah? Add 10. So 3x equals 12. And then last step, Illy? Divide by 3. So if we divide by 3, x equals 4. Now, how do I figure out the length of AB, Haley? I want to know what AB is, and this is 6x minus 10, and x is 4. What would you do? What would you do, Ainsley?
Plug it in.
Plug it in. Plug in the 4 for the x. So it's 6 times 4 minus 10, or 24 minus 10, which is 14. AB is 14. So then how long's AD, Cambry? 14. Okay, they're both 14. How long do you think FG is, Maddie? 6. Because if these two are congruent, this is a perpendicular bisector, so it hits it right at its midpoint. So if EF is 6, FG is 6. All right. Now, let's see how a baggage handler handles the angle bisector theorem.
An airport has an automated system to direct bags toward the correct terminal. A baggage inspector is assigned to watch the point where the conveyor belt split to make sure the system doesn't make any mistakes. To minimize the amount of time it takes to retrieve a misdirected bag, he needs to stand equidistant from the two conveyor belts. He knows that the distance between a point and a line is the length of the line segment from the point that is perpendicular to the line. The inspector finds that the first place he stood was too close to the conveyor on his left, so he moves closer to the one on his right. He notices that when he's standing about the same distance from either conveyor, the 2 points he's measuring to are about the same distance along each conveyor belt. So, to find another place to stand, the inspector picks 2 other points the same distance along the conveyors and finds the intersection of the lines perpendicular to the conveyor belts at those points. He notices that the points equidistant from the 2 belts appear to be collinear, and the line through them appears to bisect the angle formed by the conveyor belts. The baggage inspector marks the angle bisector with a line of tape on the floor, reasoning that as long as he stands over the tape, he will be equidistant from the 2 conveyor belts.
All right, what a smart inspector. All right, So he discovered that if he's the same distance from the sides of an angle, sides of basically an angle, because there was an angle there, then he was on the angle bisector. So the angle bisector theorem says this. Any point on an angle bisector is equidistant from the sides of the angles. So BD will be the same length as DC. Okay? So if you're at this point, you're the same distance away from the two sides. This point, you're the same distance away from the two sides. The angle bisector theorem also has a converse, which says if you're the same distance from the sides of two angles, or the two sides of an angle, then you're somewhere on the angle bisector. Okay, if you're the same distance, then you're somewhere on the angle bisector. So, to find the value of KL, this distance here, what do you think we do with the 2x plus 3 and the 4x minus 11, Thomas? Put them in the equation. How do we write our equation, Thomas?
4x minus 11 equals 2x plus 3.
4x minus 11 equals 2x plus 3. How do I solve that equation? First step, Jack. Subtract 2x. So 2x minus 11 equals 3. Now, what do we do to both sides, Christian, to get x alone? How do we move it? Add 11 to both sides. So 2x equals 14, and then we divide by 2. So x equals 7. So how do I find the value of KL if I know x equals 7, Jordan?
Plug in 7 for x, you get 2 times 7 plus 3.
2 times 7 plus 3 is 2 times 7 is 14. 14 plus 3 is 17. This is 17. 4 times 7 is 28. Minus 11 is 17. They are equal, and they better be equal, or we did something wrong. So KL is 17. Okay. If BAD or BAD is 9x minus 16 and CAD is 3x plus 20, and we want to find BAC, what do we do with our 9x plus 16 and 3x plus 20, Ella? Make it an equation. So 9x minus 16 is equal to 3x plus 20. So Jillian, what do we do on each side to solve this? Subtract the 3x from each side. So 6x minus 16 equals 20. Now what do we do to each side? Add 16. So 6x equals 36. And then what do we do to each side, Olivia? Divide by 6. X equals 6. I want to figure out what BAC is. So what am I going to do with that 6 to figure out what BAC is? What couple things do I have to do? Illy. Okay, so if I plug 6 in there, 9 times 6 is 54. 54 minus 16 is what, 38? So this angle is 38. This angle is 38. 38 and 38 add up to 76. So that's what BAC is. So what we learned today is the perpendicular bisector theorem. The perpendicular bisector theorem says if a point is on the perpendicular bisector, it's an equal distance away from the endpoints of that segment. The converse of the perpendicular bisector says if a point is equal distance away from the endpoints of a segment, then it's on the perpendicular bisector. The angle bisector theorem says any point on the angle bisector is an equal distance away from the sides of the angle. And if you have equal distance away from the sides of the angle, you must be on the angle bisector. Okay? So, today, not a lot of work. Okay? We're only going to do one section. So, anybody who has a little makeup stuff to do can get the makeup stuff done. And the section will not take a super long time. So you basically have an hour to do 10 problems. So in other words, get your stuff done in here and then get your stuff done in whatever other classes you need to get it done for.